October 24, 2003, Concorde makes its final landing. The age of civilian supersonic travel dies. The reason wasn't economics or technology, it was noise. Specifically, this sound, that sonic boom louder than an explosion. Rattling windows for miles made supersonic flight over land illegal. For 50 years, that seemed like the final word. Until January 2024, when NASA rolled out an aircraft that looks like it escaped from a science fiction movie, the X-59. It doesn't break the sound barrier, it whispers through it. This isn't just another experimental plane. This is NASA's attempt to rewrite the fundamental rules of aviation physics. And it could make New York to LA in 2 hours, not just possible, but normal. The physics problem. First, let's understand why supersonic travel was banned. When an aircraft approaches the speed of sound, about 767 miles per hour, at sea level it starts compressing air molecules in front of it. At exactly Mach 1, these pressure waves combine into a single violent shockwave, the sonic boom. Think of it like a boat on water. At slow speeds, you get gentle waves. At high speeds, you get a sharp wake. Now imagine that wake is a wall of air pressure, moving at the speed of sound, hitting everything in its path with the force of an explosion. That's what rattled windows whenever Concorde flew over land. In 1973, the FAA banned supersonic flight over the United States. Other countries followed. Overnight, supersonic travel was confined to ocean crossings. Concorde could only fly supersonic over water, which killed its economics. If you can't fly fast over populated areas, you can't connect the cities people actually want to connect. The 50-year quiet revolution. While Concorde was retiring, NASA engineers were already asking, what if we could reshape that shockwave? What if instead of a single violent boom, we could create a gentle thump? They started with simple models in wind tunnels. The discovery was counterintuitive. The shape of the aircraft determines the shape of the sound. Long, slender aircraft create weaker, more spread out shockwaves. The problem was making that shape flyable. Enter the shaped sonic boom demonstration program in 2003. NASA modified an F-5 fighter jet with an elongated nose. Test flights proved that they could reduce boom intensity by 30%. It's not enough to lift the ban, but proof that physics could be tricked. For 20 years, research continued in secretive NASA facilities. Supercomputers modeled millions of aircraft shapes. The goal, reduce the boom from 105 decibels to 75 decibels. In 2016, they announced the X-59 QueSST quiet supersonic technology. The quiet revolution had a name, the aircraft that shouldn't fly. Look at the X-59. It looks wrong. The nose is 38 feet long, 1/3 of the entire aircraft. The cockpit has no forward window. Pilots see through a 4K monitor system called the external vision system. The wings are swept back at extreme angles. The engine is on top to shield the ground from noise. Every centimeter is calculated to manipulate air. That absurdly long nose. It creates a carefully timed series of mini shockwaves that cancel each other out. A smooth underbelly, it prevents turbulent air from forming additional booms. The canards, those small wings near the nose, they control airflow to keep shockwaves separated. The target, perceived level decibel of 75. What does that mean? Concorde's boom was 105 pldb, like a thunderclap overhead. The X-59 aims for 75 pldb, like a distant thunderstorm, or a car door closing down the street. That's the difference between illegal and acceptable. But here's the genius part. NASA isn't just building a quiet plane. They're building a flying laboratory to prove to regulators that supersonic can be quiet enough. Every flight collects data to convince the FAA that the 1973 ban should be replaced with a noise standard. The QueSST mission in 2024, the X-59, begins its real mission. QueSST, the quiet supersonic flights over land mission. Phase 1, test flights at NASA's Armstrong Flight Research Center in California. Phase 2, fly over specially selected U.S. communities in 2025. But here's what makes this scientific mission brilliant. They're not just measuring noise with instruments, they're asking real people. Selected communities across America will hear the X-59 fly overhead at Mach 1.4, about 1,000 miles per hour. Residents will report what they heard through a smartphone app. Was it a boom, a thump, or nothing at all? This human data is crucial. Regulations are written for people, not machines. If people report, "I heard a distant thump," like my neighbor closing their car door, that becomes the evidence to rewrite 50 years of aviation law. NASA will deliver this data to the FAA in 2027. If successful, the FAA could replace the blanket ban with a noise-based standard. Suddenly, any aircraft meeting 75 pldb could fly supersonic over land. The market would open overnight. The race to market. NASA's X-59 isn't meant to carry passengers. It's a technology demonstrator. But several companies are already designing commercial versions. Leading the pack, Boom Supersonic with their Overture jet. They claim it will carry 65 passengers at Mach 1.7, running on 100% sustainable fuel. But Boom has a problem. They need the FAA regulations to change. Their entire business model depends on overland routes. That's why they're watching X-59's tests closer than anyone. The data NASA collects could make or break their $6 billion in orders from United, American, and Japan Airlines. Other players include Aviation, though they folded in 2021, Spike Aerospace, and whispers that Airbus and Boeing have quiet supersonic projects in their skunkworks. The prize, a $260 billion market for fast business jets and revived commercial supersonic travel, the economics are compelling. Supersonic could make New York to London a 3.5-hour commute, Los Angeles to Tokyo in 6 hours instead of 11. For business travelers, time is money. For airlines, faster turnarounds mean more flights per day. The technical hurdles, quieting the Boom, is only half the battle. Supersonic flight faces 3 other massive challenges. First, fuel efficiency. The Concorde burned twice as much fuel per passenger as a 747. New engines and aerodynamic designs promise 30% better efficiency, but it's still thirsty. Second, emissions. High-altitude supersonic flight releases pollutants directly into the stratosphere. The environmental impact isn't fully understood. That's why Boom promises sustainable aviation fuel, but SAF production is currently at 0.1% of global jet fuel supply. Third, sonic boom carpets. Even a quiet boom affects a swath of land 30 miles wide under the flight path. At 60,000 feet, that's a lot of people. The X-59's 75 PLDB target is 4 directly underneath. At the edges, it should be nearly inaudible. But convincing communities will require proof. Then there's cost. Boom estimates Overture tickets at business class plus about $5,000 New York to London. That's accessible to businesses, not tourists. The dream of affordable supersonic travel for everyone. That's decades away, if ever. The bigger picture, the X-59 represents something bigger than fast travel. It represents a fundamental shift in how we regulate technology. The 1973 ban was a blunt instrument. Too noisy equals illegal. What NASA is proposing is nuanced. Here's how quiet we can make it. Now let's set standards based on that. This approach could transform other areas of aviation. Urban air mobility faces similar noise challenges. Electric aircraft have unique sound signatures. The X-59's methodology combining computer modeling, flight testing, and community feedback could become the blueprint for integrating any new aviation technology into our lives. There's also the national pride element. The U.S. lost the first supersonic race to Concorde. Now, with X-59, they're not just catching up, they're redefining what winning means. It's not about being first. It's about being sustainable, acceptable, and integrated into daily life. The timeline to reality. So when might you actually fly supersonic over land? Here's the realistic timeline. 2024 to 2025, X-59 test flights and community overflights. 2027, NASA delivers data to FAA. 2028 to 2029, FAA establishes new noise-based regulations. 2030, Boom's Overture aims for first flight. 2032 to 2035, first commercial routes. 2040 plus, potentially affordable supersonic travel. That's assuming everything goes perfectly. Aviation history is filled with promising projects that failed, but the X-59 is different. It's focused on regulation first, market second. It's solving the fundamental barrier before anyone builds the product. The X-59 isn't just an experimental aircraft, it's a philosophical statement that technological progress shouldn't mean choosing between speed and livability. That with enough ingenuity, we can have both. For 50 years, we accepted that the sound barrier came with an acoustic price too high to pay over our homes. The X-59 asks, what if we were wrong? Whether it succeeds or fails, it represents humanity at its best, identifying a problem, understanding the physics, and engineering a solution. In an era of incremental improvements, the X-59 dares to reimagine something fundamental. It dares to ask, what if faster didn't have to mean louder? The X-59 is testing right now. While it flies, another revolution is happening at the opposite end of the speed spectrum. Next time, we explore how electric aircraft are preparing to transform our cities, one quiet, emission-free flight at a time.